All right, so this is the updated questions for 3.8 day one, for what we changed in the notes. So we have our parallel example. Yes, those are parallel. They have the same slope, but then we move to this example, which is different from previous note versions. So in order to find this slope, it's kind of hard to count because it is by twos. So basically using the slope formula where we subtract our y's and then subtract our x's is going to be a little bit easier in this example. So for DG, we're going to focus in on those points there, and we're going to look at the y values. So it's -1 and then -5. We always do subtraction in our equation here. And then on the bottom, we're going to do our x's, so -2 minus 12. So that is going to simplify to -6 over -14, which turns into a positive, and we can reduce that to 3 over 7. So 3/7 is our slope for DG. Now we're going to go ahead and look at EF. So again, we're going to subtract our y's. So 6 minus -1, which turns into a plus, and then 3 minus 6 on the bottom for our x's. So 7 over -3, or -7/3, can put that negative out front, doesn't have to stay with the denominator. And so notice that we do have opposite reciprocals, so yes, those are perpendicular there. This example is the same in the previous video lesson, previous notes. Example 4 is the only one that is different and new. So let's talk about that. Finding a equation in slope-intercept form for a line that would be parallel to this line and this point. So for parallel, we're going to use the same slope. So we do need to figure out what is the slope of this line. So counting rise, 1, 2, 3, 4, 5, 6. Run, 1, 2, 3, 4. So 6 over 4 can be reduced to 3/2. So that is the slope we want to use for parallel. And we want to use this point. So point slope is probably your best option to plug in. You can go ahead and graph going from this point up 3 over 2, but it might not always wind up on a nice y-intercept point to be able to see. And this one does end up at a half, but you kind of don't know for sure. So point slope is the official for sure way to kind of get that equation for the line. So then we want to plug in our slope. So here's point slope again. It's down here as well in the next example, but we'll go ahead and write it at the top. And then we have so m, which is the slope, parenthesis x minus, and then our x1, which is this coordinate -3. So double negative changes to a positive, and then we distribute. So 3 times 3 is 9, 9/2, and that you can change if you want to 4.5 if that's easier for you. And then we're going to add 1. So final answer, 3/2 x plus 5.5. And if you wanted to keep that as a fraction, you could do that for 11/2. And you can see that there would be our parallel line if you went up 3 over 2. So our perpendicular line is going to be, the slope is going to change and be a -2/3 because we flip it and change the sign. So then we do y minus 1 equals -2/3. X plus 3. Again, same points, so we're going to have everything the same except for our slope. And then we'll distribute -2. So numerator times that number there, which is -6, and then we divide by the denominator. So we get -2. And then final step, get y alone by adding 1. So our equation is y equals -2/3 x minus 1. And there's our perpendicular equation that would look like that. All the rest of these examples are the same in the previous video.